Hi guys, today we're going to problem solve using linear systems. Okay, so the hardest part about solving most problems is simply setting the problem up, okay? Once you get that finished, the rest of the problem is usually pretty easy to solve. Not always, but most of the time. So we have some key steps when we're solving a problem using linear systems. One, we're going to write a verbal model. Then we're going to assign labels. We're going to write an algebraic model. We're going to solve the equations, and then we're going to answer the original question. Now, this part right here, the last part that seems obvious, answer the original question, that's the part that people leave out a whole lot of times. So be careful that you finish the problem. Okay, so you and several other people are helping your aunt move. At lunch, you volunteer to go out and buy sandwiches. You get 6 chicken sandwiches, 6 beef sandwiches for $30. Later in the afternoon, everybody's hungry again, so you go back to the same shop. You buy 4 chicken sandwiches and 8 beef sandwiches for $30.60. What was the price of each kind of sandwich? Okay, so we need to set this problem up. First thing we're going to do is we're going to label the chicken sandwiches C and the beef sandwiches B. And we know this, we're going to get 6 chicken sandwiches, so 6C plus 6 beef sandwiches, and that's going to equal $30, okay? So there's our first equation. The next one, we buy 4 chicken sandwiches and 8 beef sandwiches, and this time it costs us $30.60. So we've set up the problem. Now, with this, it's pretty obvious what the labels are. You don't need to write them down, chicken and beef sandwiches, okay? But sometimes you get really complicated equations or you get a lot of variables. You might want to write them all down sometimes. Okay, what was the problem, or what was the price of each sandwich? I just got to solve this. Okay, so let's see. I would probably solve this by multiplying this bottom equation by -3, and the top equation by 2. So once I do that, I'm going to get 12C plus 12B is equal to 60. And the bottom equation, I'm going to get -12C minus 24B is going to equal, what is that? -90, 180 or something. This is why we have calculators. 30.6 times 3. Yep, 91.8. Okay. So I'm going to combine my equations now. I'm going to get -12b is going to equal, what is that, -31.8. And then I'm going to divide both sides by -12. And b comes out to be 2.65. So I know the beef sandwiches cost $2.65. Okay, then I'm going to take that value, plug it back into one of the original equations for B. So 6C plus 6 times 265 is going to equal $30. Okay, so 6 times 2.65 is 1590. So 6C plus 15.9 equals 30. I'm going to subtract 1590 from both sides. And I'm going to get 6C is going to be, what's that, 14.1. And then I'm going to divide both sides by 6. And 14.1 divided by 6 is going to be $2.35. Okay, so I've figured out the values. Now I just need to write down the answer. Okay, so the beef sandwich is $2.65. The chicken sandwich is $2.35. And I am done. What a pretty problem that is. Okay, moving right along. You're quoted a total annual premium of $1,154 for auto insurance. So premium is how much you pay annually, so for the year for your auto insurance. This premium gives you liability coverage of $1,000 and collision coverage that has a deductible of D dollars. Okay, so liability insurance is what you pay if you harm somebody, and collision insurance is paid to you if somebody hits your car or something like that. So the insurance agent tells you that if you're willing to increase your collision deductible by $400, you can get 5 times the liability and still save $72 a year on your premium. What's the amount of the liability coverage in the first quote? Use the premium schedule below. Okay, so here's what I know. I know that my liability is $480 plus 0.31 per thousand of liability insurance. I'm going to add to that my collision deductible, which is $692 minus 0.49 times D. That's deductible, and that's going to equal $1,154. So I got my first equation there. Liability in thousands, D in dollars. Okay. Now, my second equation, it says if I'm willing to increase my deductible by $400. Okay. So, in that case, my deductible now is going to be $692 minus 0.49 times D plus 400. And then my liability, I can get 5 times as much. Okay. So, I'm going to get, let's see, that's going to be 480 plus 0.31 times 5L. And I add that together, and I'm still going to save $72. So 1,154 minus 72. So it's going to be $1,082. So this is going to equal $1,082. Okay. Now, I want to consolidate these problems and make them a little bit simpler. So I've got like terms here and here. So 480 plus 692. This is going to be 0.31L minus 0.49D plus 1172 is going to equal 1154. And then the second equation, I still have 480 plus 692, so that's going to be 1172. Okay, so 0.31 times 5. 0.31 times 5, that's going to be 1.55 L. And then this is going to be minus 0.49 D minus, I'm going to have to move this, minus 0.49 times 400. So I'm distributing this in here. That's going to be 196. And that's going to equal 1,082. Okay, so I can consolidate this even more by moving this over here. So this is going to become 0.31L minus 0.49D. And that's going to equal 1154 minus 1172. So that comes out to be negative 18. And now this is going to be 1.55L minus 0.49D. Okay, I'm going to combine these two right here. So 1172 minus 196. That's 976, and then I'm going to subtract that to the other side. So 1,082 minus 976. It's going to be 106. Okay. So now I got my equation set up. This piece of cake now. Okay, I'm going to go ahead and take this equation right here, multiply by negative 1, because that will give me negative 0.31L plus 0.49D is going to equal 18. And I can combine these and the D's will go away. So 1.55 minus 0.31, that's 1.24. L is going to equal 124. And then I divide both sides by 1.24. And I get L equals 100, which really means $100,000 worth of insurance. Okay, I'm going to take this, I'm going to plug it back into here. Let's actually take this, make it that color. Okay, so it's going to stand out a little bit. And now, let's see, 0.31 times 100 minus 0.49D is going to equal negative 18. So this is actually 31 minus 0.49D is negative 18. I'm going to subtract 31 from both sides. Now this is convenient. Negative 0.49D is going to equal negative 49. And so when I divide by negative 0.49, D is going to come out to be 100. Okay. So what does this mean? This means I have a deductible of $100, and I have liability of $100,000. Okay. There we go. Okay, in 1980, the population of Illinois was 11,427,000. The population of Florida was 10,195,000. By 1990, the population of Illinois was 11,467,000, so it increased 40,000. The population of Florida was now 13,003,000. Over the 10-year period, both populations increased at a rate that was approximately linear. Estimate the year that the population of Florida passed the population of Illinois. Okay, this is definitely a graphing type problem. So I've taken the liberty of graphing this right here. Let's make this a little bigger. Okay, so my y-intercept for Illinois is right here. Okay, that's going to be the 11,427,000. Okay, and 10 years later, that's going to be this point right here. That population is going to be 11,467,000. So that's almost a flat line. Okay, then Florida starts out at 10,195,000 right there. And it increases 10 years later to 13,003,000 over here. So I draw both those lines and they intersect right there. Where is that? Well, if I follow this down here, okay, that is somewhere between 1984 and 1985. So that would be the year 1984 is when the population, so we'll say in 1984, the population of Florida exceeded that of Illinois. Okay, if I wanted to know the population at that time, I could find out. I'd probably use a graphing calculator. I'd come over here and find out what that population was in millions. Okay. All right. So I've got a little assignment for you. It's got 5 little problems. Have fun with that, and I will talk to you guys later.